Hey guys, today I'm looking at square roots. So square roots, this symbol right here, okay, let's say I have the square root of 4. Okay, so this is read square root of 4. What this is asking us is, can we split 4 into the product of the same number? That means, can I find a value that I can multiply by itself to give me 4? The first 12 square roots you should know. It's just one of those things that's easier if you know them right off the bat. But what this is really coming from is, if I did a tree for 4, what can I multiply to give me 4? Well, I can do 1 and 4, but that doesn't really break it down anymore. I can also write 2 times 2. And you want to keep doing this until you have prime numbers. But 2 is prime, so I can't go any further. So I'm going to circle that. And then the other 2 is also prime. So the prime factorization for 4, I can rewrite 4 as 2 times 2. Now keep in mind, that's still under the radical. That's equivalent to the square root of 4. But when you're dealing with a square root, it's asking, do I have a pair that when I multiply it together, it gives me the value here, 4? Well, I do. I have a pair of 2's. So for each pair under a square root, okay, and this is understood square root, okay, there's no number here. This is called the index, but if there's anything written there, okay, let's say there was a 3, we'd be dealing with a cube root. We would want groups of 3. But when there's nothing written there, it's understood to be a square root. So for each pair, I can bring out 1. So bring out a 2 for that pair. And there's nothing left under the radical, so I'm done. So the square root of 4 ends up equaling 2. And for right now, we're just going to talk about the perfect square. So let's look at perfect squares. So the first set would be 1 times 1. 1 times 1 is 1. So this 1 is the first perfect square. Then we've got 2 times 2, which is 4. So 4 is a perfect square. If you keep going, we've got 3 times 3, which is 9. 4 times 4 is 16, so 16 is a perfect square. Then if we did 5 times 5, we'd get 25. That's a perfect square. 6 times 6, I'm going to come up here. The next perfect square is 36 because that's 6 times 6. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. Of course, we could keep going. But if I wanted to take the square root of any of these, let's say I want to take the square root of 49. That is simply 7. Since 49 is a perfect square, 49 is equal to 7 times 7. So I do have a pair of 7's, and that's why the square root of 49 is 7. Also, let's say that I had the square root of 30. Well, we looked at perfect squares just a second ago. We had 1 times 1 is 1, 2 times 2 is 4, and then there was 9, 16, 25, because that's 5 times 5, and then 6 times 6 is 36. So the square root of 30 is not a perfect square. But if you look at these perfect squares, 30 falls somewhere in between 25 and 36. So I know that the square root of 30 is going to be somewhere between 5 and 6. Because the square root of 25 is 5, and the square root of 36 is 6. So the square root of 30, which is between those two, must be between 5 and 6.